Nat Cole's Unforgettable brings you to that unforgettable talk show, Viewpoint. 96.3 each Wednesday morning, WLCN at 0815 to 0900 hours. That program brings you scintillating guests of every hue and cry. And I'm going to cry that right over to you, Mrs. Busby, so you can introduce our scintillating guest, because we do have this morning a gentleman who is some renown, to himself anyway. No, we're happy to have this gentleman.
Well, I guess this is really going to be interesting.
Yes.
You know, we all see all these, we keep calling them windmills, everywhere, and they're just proliferating, and they're so interesting. And I, for one, probably not Bill, because he's the smart one of us, but
taking funny cigarettes again.
I look at those things and I think, how do they do that? And now we're going to find out. Stan Komperda is with Highlander Renewal. That be renewable energy. So he is going to explain us how this all works. And now next time you go for a ride in the country, you look at those and wow your friends and neighbors with what you know about it. So Stan, I'm so glad to have you here.
Thank you so much.
I don't think I'm the only one who's completely in the dark about the renewable energy business.
No, but I want to call Mr. Ice's attention to the way you just finessed into that. I take my hat off to you, young lady.
Young?
Well, you done good.
Who are you talking to?
Stan, we really appreciate your taking your time here and driving here from Springfield, Illinois.
Happy to be here.
We see windmills everywhere. We look south, we look north, we look west, we look east, and we find windmills. We're being surrounded by windmills, developing energy. So let's take it from the top and say, number one, how do you determine where you're going to put the windmills?
So thanks again for having me. Yeah, it's been a remarkable 10, 15 years here in Illinois, especially central Illinois. The industry's really taken off, and Illinois has the kind of unusual distinction of being a crossroads in many ways. Again, we used to be the crossroads of railroad. We used to be the crossroads for interstates, and now we're the crossroads for renewable energy.
Yeah.
And we have so much grid available in Illinois, these high voltage lines that basically cross here in central Illinois, northern Illinois. And we have a good wind resource, and then we have landowners that are willing to consider the option of putting up a wind farm or a solar farm on their land. So we have kind of those three important areas that really draw attention here to Illinois and make this development possible.
And these little windmill groupings are kind of clumped, so to speak. If you drive towards Decatur, you're going to see all kinds of them, and I bet you can see 100 windmills from your car window. And as you move, that hasn't changed. And we look west now. We started in the Burtonview area and moving on towards on Route 10 going west. How do they study that? Where do you get your information where the prevailing winds are going to be?
So one of the first things we do is we go out and we put MET towers up, meteorological towers. And these are small 60-meter towers generally. They can be 80. The taller you go, you need a flashing FAA light on there.
Yes.
But generally we'll put up these 60-meter towers. We will space 3 or 4 of them over an area of about 15,000 acres. And each meteorological tower has a anemometer, which is the little spinning cups. I'm sure that you've seen these that measure the wind speed. They're at 30 meters, which is roughly 90 feet, 45 meters, which is about 150 feet, and 60 meters, which is just shy of 200 feet. And what we're doing is we're measuring the change in wind speed with altitude. Once you get above 90 feet, the wind speed dramatically increases because you're away from all that surface roughness, the trees, the crops, the homes. All that stuff is slowing down the wind as you get closer to the surface. But once you bust above 90 feet, it really takes off, and that's called shear. And so we want to measure that shear component. And we're also measuring the main direction that the wind is blowing from at different times of the year. And so with that, we generate a wind rose, and we generate what our average wind speeds are at a given location. And that helps us determine how we're going to lay out turbines in a wind farm.
Now, as we see them in a clump, is that because those particular landowners have given permission, or is it because that's where the wind is stronger?
It's a little bit of both. So obviously we can't put any kind of equipment on land that hasn't signed to a project.
Well, yeah.
We don't have there's a lot of mistaken belief that we have eminent domain. We don't have eminent domain out there. If you don't want a wind turbine on your farm, you won't get one.
Simple as that.
I'm sorry?
It's just as simple as that.
Yeah, it's just as simple as that. Yeah, basically. And so we want to work with landowners that are close to each other so that we have pathways then to connect cables. But we will then take all the leased parcels, we will take all that wind data and we will conduct a microsighting. And that's basically a computer program that's going to put turbines on those signed parcels and move them around in various configurations. And then that'll change if it's a different model of machine as well. That then tells us what the best spots are on a given parcel to put a wind turbine. And I mean, it can be a difference of 0.1%.
Is that right?
Very, very detailed analysis, because the amounts of power, if you even 0.001 can make a huge difference in annual energy production, and then you multiply that times the life of a project of 30 years. It's tremendous amounts of power. So quite a bit of careful analysis in that.
Now, you mentioned about these cables that you have. What's with the cable business here?
So I'm generating all this power at the wind turbine. I've got a transformer at the wind turbine, and I now need to get that power over to the project substation. And so I'm going to bury cables through that farm field, and we'll cut them across the farm field, and those cables will then meet up with other cables that'll go to a thicker trunk line. That all runs to a project substation, and then there's a transformer there that steps that power up to meet the same voltage that's on the local power lines on the big grid that passes.
There's a heck of a lot of science involved in this.
There's quite a bit of different technologies involved in
648-5510. Our guest this morning, Mr. Stan Komperda, and Stan has made this trip to Lincoln to tell you about these windmills that we see around the county. We're kind of awed by their size, and those, if we get up close to them, we kind of look at the propellers and see the different pitch on the propellers and so forth. And then we see these trucks come through, most of them, I believe, from Clinton, dragging the towers around. So there are a lot of questions. If you have any, feel free to call Stan, 648-5510. Now, sir, when you come to a farm site, and as you suggest, the farmer has to agree to that. Do the payments vary from farm to farm, or are they standard payments?
So it's generally with the lease agreements, everyone's going to make the same amount in the wind farm project in terms of per turbine or per acre. It depends on how the lease is broken up by that particular developer. We, for instance, we pay per acre, so that each acre on the parcel gets paid, and then if you get a turbine, you get an extra payment, of course, for hosting the turbine, and then there's some ancillary payments for the underground power lines that run across your field, and then the road as well.
But that doesn't interfere with your farming operation, does it?
No, it's very minimal. This industry gets along fabulously without agriculture. I mean, we're taking 1/4 to a 1/2 acre out of production, and the majority of that is the access road into the field, and the farmer gets to use that as well. You can get a grain truck down that access road. It's dry and durable enough to handle a grain truck even when it's wet. So I think it's a benefit to the farmers. I think the actual footprint of the turbine is usually less than 2,000 square feet, where the actual turbine sits and the gravel road around it. Yeah.
Do many farmers, after you've talked with them, deny you?
It's about 65% is the average of people that we get will sign within a project area. There's some people that will say no, and then they'll think about it more over time, and they'll say, well, if I have to look at these things, I might as well make some money out of it. They'll talk to their neighbors, they'll talk to their relatives, they'll talk to other farmers around the state. I mean, we're not a new industry. We're mature. We've been here for 15 years, and people are they paying you? Have they fixed your drain tiles? That's what they want to know.
The drain tiles, you said, that's a big issue.
That's a big one, and farmers want to make sure that their fields are going to be dry.
And we have some sponsors that pay us to talk about their good services and goodwill. So we'll defer to them right now, Mr. Ash. Right back live in the studios here at WLCN. The program, of course, is Viewpoint. Our guest this morning, Mr. Stan Komperda, and he's going to is telling us, a very knowledgeable gentleman, certainly a real professional, and he's trying to explain to Judy and I about our wind directions here. And every time you go out at Lincoln, you're going to find a wind tower somewhere, right up not too far from here. There's a bunch of them. And as you go west or as you go east, you're going to find them. So, Stan, we were asking off air about the pitch on the propellers,
yeah.
And you explained that very, very perfunctorily. It's just like you said, is you put your hand out a car window and you turn it, and the wind brings it up. And if you turn it the other way, it won't bring it up. So, and that explains pitch on a windmill propeller.
Yeah. So are these blades not in a fixed position?
They're not in a fixed position. They will actually pitch to catch as much wind as they can. So
now,
at lower
is that
wind
done
speeds,
automatically, sir?
It is done automatically. Yeah,
That's amazing.
These systems are heavily kind of automated with computer controls. They'll also turn the nacelle. They'll turn the whole machine into the wind within a half a degree. If there's a half a degree difference, it'll turn itself that half a degree. It's trying to catch as much wind as possible in that area.
Look at Bill, how much smarter those windmills are than I am.
I'm not going to get into that, Stan. We've seen here in Logan County the towers often. Are they made in the little village of Clinton over to our east?
I know Trinity Towers has been operating like gangbusters here the last couple of years. I'm assuming that they can roll out steel for whichever manufacturer needs it. So I don't know specifically where. I mean, it's just rolled steel, right? A tower is just rolled steel. We do that all over the U.S.
They sure are big.
It can be coming from various locations. I think some may come from overseas, but the majority of components are made.
Where are propellers made? Various places?
There's a couple companies, LM Glass Fiber. There was actually a facility down in Arkansas, near Pine Bluff, Arkansas, that was making propellers. Colorado. It depends on the manufacturer, right? So GE, Siemens, Vestas, these are kind of the big three guys. They have facilities all over the U.S. Nordex does, I believe, as well. And so, specialized factories where they're making these.
They appear to be metal, and you just indicated that they are not indeed metal.
No, the rotors themselves are composites. There's actually wood in them sometimes.
Really?
Fiberglass, carbon fiber. Resins, they're impregnated with these resins. They're pretty tough.
Is that for the weight or density? Or?
Yeah, each one weighs about 6 tons generally. So they're trying to keep the weight off. Each blade, yeah.
Holy Friday.
Yeah, it's they're heavy. They're heavy, but they're also having to carry that weight out hundreds of feet.
Yeah.
So they've got to be structurally very sound, and that's why you'll see them. It looks, by the time it comes into the nacelle, it's this big round tube, and that's distributing that load into the
now,
hub.
Mr. Komperda, you indicated that if there's suddenly a high wind, say a storm,
right?
Those impellers, I use that word as opposed to propellers. Am I correct there?
Sure, you could.
They sense that electronically, and they will shut themselves down.
Yes, they will pitch out of aerodynamic, and within seconds that entire spinning wind turbine will stop, and that's generally around 50 miles an hour. And they'll wait until the wind speeds die down, and then they'll just pitch themselves back in
and can sense that and turn it back on.
And turn it right back on again. Yeah. They can also be shut off remote by the technicians. They can be shut off remote by the actual manufacturer. There's all kinds of safety.
Why would the manufacturer shut down some?
Well, in some cases, the manufacturer is actually conducting the O&M of the facility, so the operations and maintenance. So you may have somebody that buys a wind farm. You may have a big industrial company, say, that buys that wind farm and they want all that power, but they don't know how to run a wind farm. So they'll contract with the manufacturer of the turbines, GE or Vestas or whoever it is, and they will then make sure the wind farm is operating at maximum efficiency, and components are being replaced as needed, and that, so they can shut it off remote. They'll have their headquarters worldwide, and they can shut these things right off.
Wasn't there a just lately announced a variation on the makeup of the blades, the actual blades to these windmills, in that there was going to be a slot in the. Am I lying?
In the blades, I haven't heard of anything like that. I mean, I know there's carbon fiber, fiberglass, wood is kind of the main components. There's all kinds of doodads that you'll see attached. Some of the blades will have a little sawtooth pattern on the back edge. Some of them will have vortex generators. Any of you pilots out there will know what those are. And we're trying to keep as much wind clinging to that blade for as long as possible to squeeze out kind of the last bits of power out of it. And so they're always making these little improvements that'll gain 1% or 2% to annual energy production. And that doesn't sound like a lot, but it's a huge number.
Okay, so we've reproduced this from tower number 22. We produce X number of wattage,
Right.
or whatever the term you use. How are you going to get that to where it wants to be? And
Okay.
to whom do you sell your power?
Okay, so the way it works, the way the grid works, is we have these high voltage lines running across farm fields. Most people are familiar with the H towers, the two wooden poles, and that's 138,000 volts. The bigger lines that are further north and east near Decatur are on the metal lines. Those are 345,000 volts. So the higher the voltage, the farther that power can go, hundreds of miles with lower losses. So what we need to do is the power that we're producing at turbine 22, for instance, we need to get that voltage to match what's on those power lines. So we have cables that run underground from turbine to turbine, and they'll go to a project substation, and at that substation we'll have a transformer, and we're going to step up that voltage from the turbines, which is 34.5 kV, so 34,500 volts, to match what's on those power lines that we want to inject to 138,000 volts, let's say, like here at Sugar Creek. So that power is now racing around the speed of light or close to it, right? It's going wherever the demand is. If it's running up to Bloomington that morning because it's hotter up there for some reason and people have turned on their air conditioners, it's basically racing around on these lines.
Really?
The big hole for power, of course, is Chicago, St. Louis.
Yeah.
The more people you have, the more load on that system. And so all that energy is running up there. And I do get questions sometimes. Farmers will say, well, where's all this power going? Is this going up to Chicago or the East Coast? Just like your corn and beans are going over there. Because you guys aren't eating
Wherever the market is.
It's going where the market is, and that's where the demand load is. So that's what we're doing. And we've had so much coal shut down here in Illinois that we have all this capacity available on these lines that there wasn't 10 years ago. And now there's more capacity. We can inject more power. There have been some line upgrades. Ameren's come through and put some new lines in, and that's real beneficial for renewables here in Illinois. And that's why we're the hot spot right now. It's unbelievable how much attention is focused on Central Illinois and even South Central Illinois here in the near future.
Will there be a time? Well, obviously there's going to be a time. Bill, dumb question. As Amos Nandy says, I withdraws the question. No, I'll proceed with my dumb question. At some point in time, you have a saturation point. You can only put so many towers up,
Right.
And there's only so much wind that you're going to take advantage of.
Right.
So, how do you determine that, Stan?
So what we have to do is grid studies, and this is real expensive, right? If I can't just go out and put a wind farm in and plug into those lines.
Sure.
They're called regional transmission organizations, and they kind of manage the power flows in and out of these lines. So even though Ameren might own the lines or ComEd owns the lines, there's an organization called MISO out of Indiana, Midwest Integrated Systems Operator. They do the calculations, and they say, okay, Stan, you want to put 200 megawatts in at this location, and they make sure that, I'm not going to blow breakers 100 miles away on another thing because the power flows aren't correct. So they do all those calculations. It used to be a 2-year process. Now it's a 3-year process because there's so many people piled into those queues. So they're the ones who analyze that and make sure that we can inject power at the right locations on those lines.
So when I was a kid in school, if you see a kid running around the campus with a slipstick on his belt, you have a bunch of slipstick engineers.
We do. Yeah.
With the computer replacing the slipsticks.
Well, there's quite a bit of analysis that's done, not just microsighting, electrical analysis. I mean, it's a big.
So
big
I
industry.
can't just call you up and say, I'd like you to put a windmill on my property.
If you called me up and said, "Hey, I'd like you and 5,000 acres of my late neighbors would like to put stuff," we might be able to start a conversation.
Well, yeah, then we're
need,
there.
Yeah, we do need some large areas, and we do need access to power lines, and in some cases, we have to run. We have to run our own power lines, several miles to interconnect to the right point. MISO might come back to us and say, "Well, we want you to put that power right here on this sweet spot on the grid."
648-5510. If you want to know about these windmills we see in Logan County, and they sure do proliferate, and we'll see a lot more. Am I correct in that, sir?
There's a couple more projects that are definitely out by Mason City. There's going to be 2 new projects.
Oh, you got a huge project going.
I'm working on another one down near Elkhart. It'll be west of Elkhart here. That'll be built probably another 2 years. I think the folks from Invenergy are out around northeastern Logan County there. But like you mentioned, there is a grid saturation point at some point, and we're not there yet, but we'll be getting close to it here in the next couple of years.
And what can you define that saturation point?
Well, it's the power lines can only handle so much. Only handle so much juice. Then you start having thermal issues, and you have to do major upgrades. If you're getting to the point where you have to do tens of millions of dollars in upgrades to the network, to other grid locations around, to get your project built, that's really going to start defining what the limits are. Now, if these coal plants continue to go offline, if Powerton goes offline, if Prairie State down in southern Illinois, if a couple of the nukes shut down up north, that will free up some more capacity on the grid. Those power flows can increase. And they have finite lifetimes as well.
Do you think it's inevitable that we will see shutdowns of more coal mining facilities?
Well, there's not much. To my knowledge, there's only really 3 operating plants right now in Illinois. CWLP in Springfield, Powerton up near Peoria there, up near Pekin, and then Prairie State down in southern Illinois. And from what I understand, with what the governor and the legislature have just passed, that's all going to get phased out by 2045. So 25 years, and we probably won't have any more coal plants operating. It will be nuclear, will be gas, and will be renewables.
Now we read, not supposed to pay too much attention to what you read in the paper, but anyway, the Springfield what I call the V.Y. Dahlman plant,
right,
is that was named for a former editor, State Journal Register years ago. In any event, that's a coal-fired operation.
Right.
They're having some problems with that right now. Does that mean that they'll be going to a different source of power?
I don't know what CWLP's master plan is right now in terms of phasing out coal, and we do have that new plant that's only, I think, 10 years old. The problem is you need to start doing, if you're going to start importing power into Springfield or in any large city, you need to make sure those power lines can handle it, that there's enough power lines coming in, and that those lines are upgraded. So that's something that has to be taken into consideration as well. But I don't know. I can't speak to the specifics as if they're having issues with the coal plant or not. But my understanding right now is everything's supposed to be phased out by 2045. And
now, a big item with when you're going on to Farmer X, I want to talk to him about leasing his ground to put a tower up. Then you want to run cables to transmission stations and so forth. The big thing you run into, of course, is drainage tile.
Yes.
And that's a very, very important thing to the farmer. And you cover that in your leases, and I presume then you hold them, they hold you responsible for any problems.
Correct. So there's kind of 3 layers of protection for landowners with drain tiles. Number 1 is our lease. We commit to fixing any drain tiles, and there's also a warranty period there, so that for years afterwards, after the construction's completed, if there's a problem, we've got to go out there and fix it. There's also the county ordinance, which says that we have to do that as well. And then most recently, the state of Illinois has gotten involved with these AMA agreements, which is an agricultural impact mitigation agreement. So the Illinois Department of Ag says, and we have to sign this with them, you will do the following things. And it speaks to drain tiles, decommissioning funds, all the things necessary to protect the family, the family farm. And we want to do that. It's our reputation as well, right?
So, Mr. Komperda, if you'll put your headset on, I think we do have a caller. I think he has his headset. Go right ahead, caller.
Good morning, Bill and Judy, and thank you, sir, for taking my call. I'd like to ask a few questions, please, and then I'll hang up and listen to your response. I'm just wondering, what is the approximate lifespan of a wind turbine? How are they disposed of at the end of their useful life? And wondering, are any of those materials they're made of biodegradable? And also, are they generating any power when they're not turning? Thank you, and now I'll hang up and listen.
Okay.
Did you get that, Stan?
I hope I can remember them all. No, that was
hearing is
good questions. Mm-hmm. So the typical life of a wind turbine is about 25 to 30 years. The life of the project, essentially. You might start seeing gearboxes being replaced at some point, 20, 25 years. If that's going to happen, as with anything else, they're more efficient. They'll put in a newer gearbox that'll run more efficiently. The towers themselves are basically just rolled steel. It's a rolled steel tower. Up at the very top in the nacelle, there's a gearbox, which is a transmission, just like the transmission in your car. And that gearbox is all steel. And what it does is generates a consistent RPM for the generator in the back. So you've got steel and you've got copper, and there's a significant salvage value associated with that.
Yeah, right.
Now the rotors, and this is something that's come in the news lately, is the rotor. Well, what happens to these rotors? Well, so the rotors are essentially fiberglass, carbon fiber, some wood, but they have a very tough resin in them, and they're looking at various ways to recycle these right now. I've heard that there's a cement kiln that's going to be grinding these things up to burn them, basically, because there's a BTU value in there to produce cement. But there's nothing really biodegradable in them. It's basically mainly steel and some copper and things that can be recycled, and they're high quality. So
I hope that helped our caller. We appreciate your call on that. We'll mark you down to 1 or 2 listeners. Stan, as you face each day, what's the biggest problem as you get in your car to go into the field? What's the biggest problem weighing on your mind?
Well,
besides another buck, another day.
It's just trying to get the truth out there. There's a lot of misinformation that's going around.
We understand.
There's, one of the ones that frustrates me the most is that, these towers can't generate the power that it took to create them.
Oh.
And I mean, that's just ridiculous. It's really the amount of power these things will generate over a lifetime is so many times more than what it took to heat the steel and roll the steel and everything else. Yes, they're high tech, but they're not that high tech. We're basically capturing some force generated by the wind. We're sending it through a gearbox to make it a nice consistent RPM for the generators, and that's it. Everything else is computer controls and that. So
There's no question but what we're going to need more power for more things that will be invented as the years go by. It's just kind of silly to fly in the face of a ready source, isn't it?
Yeah, I mean, electric power is going to be the main driver. 10 years ago when I started the Sugar Creek project, I said, the child born today will be driving an electric car.
Yeah.
And it's happening. I mean, Rivian's right up the road here. They're going to be Tesla's main competitor. We're going to have electric cars probably at most homes within another 10 or 15 years.
And they're going to take charging stations up and down the highway.
There will be charging stations. My theory is that grain elevators are going to be the cool hangout spot because you've got so much power coming into grain elevators that it makes sense for them to be the charging stations.
That's a practical thought.
And you've got substations out at wind farm projects and solar farm projects. It's a natural charging location. There's so much more power available that provided the car battery can handle that kind of voltage and amps coming in.
But that's important that you see the compatibilities.
Right. I mean, I have a lot of power coming into a grain elevator, so it makes sense. And at some point in the future, we'll probably see, batteries powering farm equipment. We'll see battery powered.
As with all things new, there are always some complaints. Some are valid, some are silly. What What about the complaints that they're injurious to birds? You heard that?
I have heard it. We are always involved with U.S. Fish and Wildlife, with the IDNR, on doing studies, on doing bird counts, how many birds we kill per turbine, things like that. And I don't mean to sound flippant about this, but really, feral cats, if you're really worried about the birds, feral cats are decimating birds way more than anything turbines add to that. It's
a 410 shotgun would handle that.
You know, there's a lot of farm cats I see running around, and they're not just catching mice.
Yeah, right.
So, you know, it really, but it's something, you know, we don't get into this industry to damage wildlife.
Of course
not. None of us. So we're conscientious. We work with the U.S. Fish and Wildlife. Now they're implementing. They'll want to stage us back from tree lines where, you know, birds might migrate more and things like that. So we work with them, and we do these things, and we mitigate as much as we can any impacts to wildlife.
Well, you're not in business to make whole segments of the population mad.
Exactly.
Once you establish an agreement with a farmer, then that is you have it dated and so forth.
Right.
And that's good as long as the dates are correct.
Sure, yeah. The leases are basically for 30 years, and sometimes there's extensions built in as well, because we think this industry will be around for a while.
Now, there might be a problem here, and you say 30 years. Well, that's really not very long in the life of the tower. You would hope that then that would be able to be negotiated at the time of the extension of that lease.
Right. Mm-hmm. And some projects, you see some projects now, for instance, the first wind farm that was built in 2005 had 0.9 megawatt turbines, and they've since repowered that facility. They took down those old turbines, and they've put up fewer turbines, but that generate more power, 3 megawatt turbines. So there's not the visual impact as well. You know, at Sugar Creek, for instance, when we first started Sugar Creek, we were going to have 117 towers, and now there's less than half. There's 57. But they generate 25% more power than what we originally planned on injecting.
How did the contracts and things work? Because in 30 years, the son could be taking over the farm on which the tower stands.
Right.
Does the lease just continue on then?
Yeah, it runs with the title of the land. So if someone passes on and it's turned over to the next generation, they then get the benefits for the project as well. Yeah. And likewise, what I've had calls from is some farm managers, you know, saying that they're selling a field that's got an operating turbine or two on it. That land is selling at a premium because the exiting farmer who's selling the land is trying to take a little bit of that profit from the wind farm on there with him. And then the new owner who's buying it sees the value of the additional cash that's coming in year to year from those two machines as well.
So how do we solve this problem of drainage tiles? Go deeper?
No, I don't think we need to go deeper. I think what we do is work closely with our landowners. You know, now with GPS, anytime these guys go out and pattern tile a field, we can get exact locations of where the tiles are. Sure. And I want to sit down and work with the farmers on this. You know, I don't want to locate a foundation on a 6-inch or an 8-inch main where a bunch of 4-inch tiles are coming in. If I need to move the turbine 50 feet or so to just get away from that area, let's do it. Let's just avoid it altogether. But mainly the biggest thing is they just want to know that things are repaired. If we cut a tile, we're going to fix it so that they don't get out there in the spring and there's a half-acre pond that's not drained. And nobody wants that. And that's where these warranties come into place in the lease, in the ordinance, in the AMA agreement. We've got to get out there and fix them, and we do, and we want to because it's part of our reputation as well.
Sure, you're right.
Now, Stan, as you drive by these airfields, you see some propellers that are just standing stationary, and that means they've been turned off at some point, either automatically or manually.
Right.
How do you turn off tower number 2 and tower number 4 and 5 are still going?
Yeah, so they can again do that remote from the office. It could be under
flip a switch from somewhere.
Literally, it's on. I've seen it on a guy's laptop where he can log in onto his laptop and just shut it off.
The farmer can?
No, the operator.
Yeah.
Oh, okay.
Right. So normally each project will have a field office staffed by a couple guys out there. They're the techs. There's the supervisor running everything, and he can shut these things off remote. So the number one reason is there's maintenance happening on it, right? They're replacing some doodads up at the top or something like that. But the other reason could be there's not a lot of power demand. A lot of these guys are selling on the day-to-day market. If there's not a lot of power demand that day, they'll turn off a couple of the machines and just let them lie until they get a need for additional power. No reason to put wear and tear on the gearboxes if it's not needed. And then the other thing that's happening is they're learning to configure the turbines. They'll turn certain turbines on with certain wind speeds because they'll operate more efficiently given a wind speed from a certain area. It's the industry's maturing, and they're just figuring out. They want to wring out as much power as they can, basically.
You can literally work out of a pickup truck.
Literally, yeah. You can drive out there and just Wi-Fi yourself into a turbine.
Yeah.
Isn't that something?
It's amazing.
Now, what do you foresee with electric cars being more important to people?
So, probably the biggest thing that's going to happen is, people in a given subdivision, there might have to be some distribution changes. I mean, where you have power lines running in the subdivisions, if you have a lot of electric cars that come home after 5 o'clock and all plug in, that's a heck of a strain on the existing power system that goes to those homes. So there might need to be some upgrades in those areas. But as far as the grid goes, we're ready. I mean, we can charge as many electric cars as they want to buy and get operating on the roads. We can handle it from the high voltage side. It's the distribution side that's gonna need some of the retooling, and that's kind of why I mentioned grain elevators might be the new cool.
I thought that was an interesting observation. These elevators are up and down the highways all over the countryside. And having them as a charging station seemed like a rather logical attempt.
You can probably do it in 10 minutes or 20 minutes at one of those locations, and the newer batteries will probably charge faster than that. So,
looking down the road, do you see more windmills going up north or south of us, sir?
South of us, I see I-64 is kind of I-64 and north will be the next development area here, south central Illinois. There's some additional grid capacity down there. I don't know if there's going to be any other big grid improvements up here, north central Illinois. If they were to put another 345 line through, that might change some things. But we'll be busy for the next 5 to 10 years, and there will probably be some repowering happening of existing wind farms. A project that's been operating for 10 years, maybe in 5 they start looking at repowering it with bigger machines, fewer machines.
All this infrastructure that's required, can it be used by other entities?
So infrastructure in terms of the voltage, it's the electricity is the main product, right? So so it can be used by people from hundreds of miles away. You can buy wind power from a wind farm hundreds of miles away and take credit to that power even though you're 200 miles away. Of course, there's the access roads into the farm fields. That helps the farmer himself. You can get grain trucks.
Ain't it just lucky they made you smart people?
There's a lot to learn. I've got a lot more to learn.
Tell me your educational background before this. There's a finite science that we're talking about here. What qualifications do you have to begin to break open in that field?
Well, it's really a wide swath. You've got environmental biologists, you've got engineers, of course, electrical engineers. I would encourage anybody that has any interest in electrical engineering to get into it right now because there's such a shortage. We really need people that are good with electrical engineering, high voltage. The battery stuff's only going to increase that demand. My own background is basically environmental science, geography. I worked for the EPA for about 15 years, so I was a project manager with doing haz waste cleanups. So that gave me some experience with construction machinery, things like that.
Do you think Edison or Westinghouse looked down the road and saw this coming?
Lincoln saw this coming.
Now there's an observation.
There's a quote from Abraham Lincoln.
Really?
And I'll send it to you guys. And our engineer from Germany actually found it, Arnie, our old engineer, and he said that he thinks that the wind is the greatest source of motive power that's untapped. Abraham Lincoln actually made that quote. I don't even remember when it was.
What if Ron Keller knows that?
Yeah, we'll have to tell him.
Remind Ron
There's
Keller.
a quote out there somewhere. Someone can look it up online, I'm sure. But yeah, he was prescient. He really kind of saw what was coming, and I'm sure that Tesla and Edison and those guys thought the same thing. So quite a bit of power in the wind, quite a bit.
So, would you go out on a limb and make a prediction that in the next 5 years we will see a 25% increase in electrical automobiles?
I would say 20%. I would say 20%. Yeah,
That's a lot.
As people become more comfortable,
1/5 more.
Right now, I mean, the Tesla's the only big company, right, that everyone's familiar with. But Rivian's rolling out cars this month, right here in Bloomington. And there's other developers as well, Polestar and other vehicles. Ford's getting into it. BMW, some of the other companies, and it will eventually just become commonplace, and everyone will probably have at least one car that'll be all electric.
Now, as I was driving west on Route 10 towards the Illinois River, do you anticipate that we'll see more towers along that corridor?
We won't see anything in the Illinois River Valley itself.
Because it's a valley.
Well, yeah, the wind speed is not as good.
Uh-huh.
The elevation begins to drop off pretty quick. So, if you notice the wind farms here in north central Illinois, they're all kind of on the tops of these glacial moraines.
Yes.
And so when the glacier was backing up, it left these hills basically that are 50 to 100 feet higher than the surrounding land. Mm-hmm. And when the wind hits that, it really increases with speed as it's trying to top over that moraine. And that's why you see around Bloomington there, they've got that big glacial moraine up there, and that was where that first big wind farm, 400 megawatts, was. Aerosmith, I think, just east of Bloomington. But those locations get tapped out quick, and you can only inject so much power into the power lines that are nearby those. But even the flat areas here in Illinois, what the big driver has been, the towers are getting taller, the blades are getting longer. And so every meter that I can reach up higher into the atmosphere, into that upper atmosphere, I can get 1% higher annual energy production. So if I can put towers that are 100 feet higher into the sky, I don't need as many towers, and I'm generating more power more efficiently. So.
But is there the material that would support one that's 100 feet higher than the ones we've already got?
Sure, yeah. I mean, we just need bigger cranes, right? Hopefully, somebody will build a self-building tower where we don't need these huge cranes anymore.
Now, Stan, so these propellers, the pitch in these propellers is variable.
It is.
And that is, do they vary in and of themselves, or do they get a button push somewhere to change the pitch?
They will do it themselves. It's all automated.
Automatic. Yeah.
Automated. As much as whatever it can do to face the wind within a half a degree of the wind direction, and whatever it can do to maintain a higher rate of rotation, those things will be all automated. Yeah.
Stan Komperda, representing, see what the name of the company is, Judith K. So
Highlander Renewal.
Highlander Renewal, which is a wind-powered generator for energy throughout central Illinois. We appreciate your taking your time, Mr. Komperda.
Thank you so much for the invitation.
And driving up. You've done. I hope you've done us a great favor, and I'm thrilled that our listeners have been interested in what we had to say. Thank you, Stan Komperda.
Thank you.
Thank you.